I am Manisha. My roll number is 21ME61A01 and I am going to do assignment on friction stir welding on ANSYS. First of all, we open the ANSYS workbench and go to fluid flow. Then after, open geometry and double click. First we change the unit to mm. Go to XY plane and right click at locate. Now we create the sketch of our part. First we will create a circle of diameter 240 mm. Then we create two chords of this circle of length 144 mm. Then click generate. Then we extrude this part in a reverse direction of depth 6 mm. Then we create a sketch of a tool pinhole on the part of 6 mm. Then click generate. Now we also extrude this sketch in reverse direction of depth 5 mm and operation is cut material. After that we create another sketch for soldiers which is of diameter 24 mm and then we extrude it for imprinting the face. Now our part is created. Now we define the surface for velocity, input, pressure, output, FSW tool, top surface and bottom surface. For this we go to tool, select name, and then we select surface and name them. Hence our geometry is completed. Side faces are automatically named. Now we will go back to the workbench and right click mesh and edit. Go to the mesh and select sizing option. In this scoping selection, we select name selection and select the FSW. Element size will be 0.5 mm in one case and 0.3 mm in other case, and then growth rate will be 1.1. Select mesh again, go to sizing and then click edge selection option. Now in the scoping selection, we select geometry, selection options and click this edge and make the element size 1 mm and growth rate 1.2. Now finally we click on the generate option and then update option. Now we go to the workbench again and click setup option. As we can see, we have about 3, 4, 6, 1 line tetrahedral cells within the block. Now in general, in this model energy equation will be on. In this viscous, the fluid is taken to the laminar and viscous heating will be on. Now in the material, we have created a material aluminum 6061. This material is created as given in the assignment problem. Density will be 2700. Specific heat coefficient is taken as polynomial and its coefficients are taken in the given problem. Same is done for thermal conductivity. For viscosity, we also know Newtonian power law. Now we select method as shear rate and temperature dependent and fill the value according to the problem. Now we select boundary condition, select inlet and velocity inlet. Now in the momentum tab, the velocity specification method is selected as magnitude and direction. Velocity magnitude is filled 1.3 mm per second. Now we will go to the outlet pressure outlet. In momentum tab, backflow reference tab is selected as absolute and directions. It will be selected as direction vector along 100. Now we will go to the wall FSW tool. In momentum tab, we select moving wall, and it will be an absolute and rotatory boundary condition. Rotating axis is Z and origin is 000 and speed is 74.35 radian per second. In the thermal tab, we assume no heat flux. Now we wall bottom faces. Since there is some good amount of thrust force that the tool exerts on the workpiece, and the workpiece is also clamped to the bottom plate. Wall motion will be moving at the speed of 1.3 mm per second, that is translations, and it is a no slip condition. In the thermal, we select convection and consider heat transfer coefficient of 10,000. Now wall top face. Again, select moving wall and speed will be the same as the bottom face, but the convection coefficient is taken as very less, that is 30. Now wall 1 solid. Again, same moving wall with same speed. The convection will be taken as 38. Now solution method. We pick up the default option in the solution method. Then the solution report definition. We add the variable that are asked in the questions. Go to the new force, report drag. First is well force, which is the force acting on FSW tool, which is the force acting, that is 100 directions, 100 directions. Second is lateral force, which is the force created on the FSW tool, which is the force in 010 direction. Third is the thrust force, which is the force in 001 directions. Last we create a momentum report, which tells us the torque on FSW tool axis is 001 and momentum center is origin. Now solution initialization. We will create a hybrid initialization, and finally we run the calculation and we take 2000 iterations. Now we have to plot total 385 iterations. Now solution is converged, and finally we run the calculation and we take 2087. Now we have to plot contour for temperature and viscosity in the well cross section area. For this we have to introduce a new plane. We go to results, contour 1. We click on create new surface named well transfer section. Option will be point and normal. Point is 000 and normal is 100, and click create. Now after creating the planes, we need to select the plane for which we have plot contour, and first select temperature, and then on contour, and finally save in display and signal for viscosity. Now we can see temperature. We can also individually each report definition solution. Solution is report definition. these are the results that we have done. Cell size 0.3 and 0.5, cell number of cells, number of iteration, time taken, peak temperature, torque, thrust force, drag force, and lift force. These are the results that we have obtained, and that is my assignment I have completed. Thank you.